Hello and welcome to Unit 3, Earth Science, which consists of Earth and weather. This year is a little bit different compared to last year. Last year, the Earth section, which consists of plate tectonics, topographic maps, and satellite views, was the only thing ever tested on any CA for any Uplift scholars. This year, because Michael has redone the CAs to be more representative of the STAR test, weather will show up on your CA, but it's not going to show up until quarter 3 CAs. So last year, the scope and sequence had both Earth and weather to be completed before the December break. This year, the Earth section should be completed in quarter 2 before December break, and the weather section should be completed in quarter 3 before spring break. You will see these two parts of the unit separated in your CAs, whereas Earth will be represented in CA number 2 and weather will be represented in CA number 3. As always, my name is Andrea Troxel. I am the 8th grade science CTL and I am currently at Infinity Preparatory Middle School. You can email me at atroxel@uplifteducation.org. The big ideas for Earth and weather deal with the C words. You have change, classification, and convection currents. What I mean by change is the Earth changes. Whether that's a long time taking millions of years, like with plate tectonics, or it's a very short change, like weather, changing from day to day or even from hour to hour. So you'll need to talk to your kids about the different types of change, and that leads to one of the debatable questions that talks about if change happens so slowly, should we even bother to worry about it? The other big idea for Earth and weather is classification. There are a whole bunch of plate boundaries all over the world, but we classify those plate boundaries into 3 major types. Likewise, we have global wind patterns, but we classify them based on which direction they're going and where the latitudes are. So there's a lot of categorizing, organizing, and classifying these natural events and these natural patterns into something that we can name. Lastly is convection currents, and that is probably the biggest of your big ideas for Earth and weather. That all of these changes, the ways that we classify a lot of times, are based on the transfer of heat through convection currents. That is why the plates move. That is why the air moves. That is what causes your global wind patterns, is based on the heating and cooling and the patterns on the Earth. On stage 1 of your unit plan, your inquiry and purpose, you can see the unit duration is split in half so that there are 6 class periods dedicated to the Earth side of plate tectonics and topographic map, and that is on CA number 2, and then 6 other class periods for weather on CA number 3. Because these are split by such a large amount of time based on from December through winter break and into January, I'm actually treating this unit plan almost like 2 mini unit plans that are kind of shoved together. So yes, there is the same key concept and related concepts for all of it, but the GRASP assignment and some of your daily lesson plans are split, so it kind of seems like 2 that are jammed together. The main focus of the unit is going to be about change, which is of course our big idea, and then we have form and movement. So form is dealing with, of course, landforms, what things looks like, what we observe. It deals with also, you'll notice, our C words of classified and categorized in there. And of course, moving, which our process of movement is going to be convection currents. The statement of inquiry is very simple this time. Movement causes changes in forms over time. The inquiry questions, or big picture questions, all center around those concepts of form, movement, and change. The first half of your unit deals with the Earth science. There are 2 readiness standards and 1 supporting standard. Your supporting standard deals with the historical development of plate tectonics, and so that would be Alfred Wagner, continental drift, and some of his fossil evidence that he used for that. The readiness standards are plate tectonics and then topographic maps and satellite views. Please pay special attention to, I highlighted the word predict. These features can be reshaped by weathering, so you might have to have a very brief review of weathering, deposition, and erosion, to help talk about how these landforms were going to be changing over time. The second half of the unit deals with weather, and all of these are supporting standards. The first standard deals with global wind patterns and ocean currents. The second one is specific weather maps and being able to read weather maps and predict weather patterns based on that. And the last one has a special focus on hurricanes. You may be asking yourself why I'm dedicating the same amount of class time to 3 supporting standards that may or may not even show up on the STAR test compared to plate tectonics, where 2 of them are readiness standards, will be represented on the STAR test, and there's the same amount of days, 6 days for plate tectonics and satellite views, and 6 days for weather. The reason that I do this is scholars are human beings on Earth, and they need to know what the atmosphere is like around them, and this is something that affects their lives every day. So I know it's not that important in regards to test taking and teaching to the test, but I feel it is very important for them as humans and as living, breathing creatures on Earth that they need to understand what's going on around them. They need to know where to safely go in their house in regards to a hailstorm, in regards to a tornado, or other significant weather event, so that they can prepare and they can be safe. Some of your interdisciplinary connections involve using your ELA classes to cite sources and research, especially with this year's major amount of hurricanes. Scholars could look into specific hurricanes, what caused them, why are they bigger than they were last year, that kind of information. You also have your humanities interdisciplinary connection when you talk about landforms being made. You can bring that in with the mythology of people and how certain native peoples believe that this landform was caused by a giant bear who made scratches in the mountain, and so that's how Devil's Tower was created. And you can see, do these myths match the scientific explanation? The other way you can relate this to individuals and societies is to talk about human geography and how Appalachian Mountains created a natural boundary, and so it took a long time for the colonies that were established to move past the Appalachian Mountains and into the Midwest. So the GRASP assignment for Earth Science, and I split them into 2. The GRASP assignment for Earth Science deals with the plate tectonics and continental drift part of things. And I was inspired on this based on the flat Earth theory that I've been hearing going around, and that some sports stars believe that the Earth is flat, and they've been told wrong their whole lives that the Earth is round. So their role is to be a scientific advisor to the President of the United States. Because the President is so concerned with fake news lately, it is your job as the advisor to sift through all the evidence that is found on the internet and create an argument for either for flat Earth, I hope that's not what they're going to choose, or to refute flat Earth. They would, in their project, create either a memo to the president or a letter to the president that cites their sources, and they can even turn that into a speech or a press conference that they have to deliver to the class outlining their data and their results. This, of course, has a connection to your statement of inquiry that movement causes changes in forms over time. So the idea is if the Earth is flat, and I don't even know what would be under the Earth if it is flat, are we a floating frisbee in space? I have no idea. But if so, how do we know things are changing? Mountains are created, how are they created? And so that deals with this idea of big time, and that if things are going so slowly we can't physically observe them, then how do we know it's really happening in the first place? The second GRASP, and like I said, I'm splitting it into 2 because one you would basically do in December and the other one you would do in January or February. So the weather one, you are a curator for the Perot Museum of Nature and Science, and I know some of you visit the Perot Museum of Nature and Science, so they will be able to see some of the exhibits there and have some firsthand knowledge of what they would look like. But basically, it's your job to talk about convection currents, weather, oceanic and atmospheric currents, and the Coriolis effect in a fun and informative way. So they are going to create their own model of an exhibit to add to the Perot Museum of Science and Nature and focus their exhibit on all types of visitors from young school-aged children to seniors and adults. This relates to your statement of inquiry and changes over time. There are a lot of changes that are happening on Earth that are happening so slowly we can't see them happen. So we're having to deal with evidence that was collected over the last couple hundred of years to be able to form these ideas. And so especially with global warming, with climate change, these are things that we aren't personally experiencing, especially if we look at climate and evidence of climate from 100 or 200 years ago. So if we have fossil evidence, ice core samples, and some of those things, scientists are making conclusions based on this evidence that they're gathering from hundreds or thousands of years ago. And as a museum curator, you're bringing that together in an easy way for people to understand. There are two possible criterion that you could use for this. If you're not using the constructed response or MYP assessment that's provided for you, you would want to use criterion A, in which you're using scientific knowledge and creating judgments that are scientifically supported. The other possibility for this is criterion D, in which you're talking about how science impacts people. So you can talk about applying sciences, using it to address an issue, and then using that scientific language effectively. If they do research, which they should in order to create a museum exhibit or to create a memo to the president, then documenting their sources correctly is part of that. For the approaches to learning, I am paying special attention to using a variety of media in order to research for these GRASS projects. So scholars may find video, they might find articles, they might find blogs, they might find pictures, they might find data. And so using all these different types of media, they will need to bring it together and synthesize one argument. The other thing is gathering together all that information to formulate their argument. Part of that would be guiding, and perhaps through the technology class as well, internet research, how to determine credible sources, how to cite sources, and how to, once you have your information, create one argument using all these various sources. For differentiation, I mentioned the Blue Marble Earth Lab that is provided by NASA, and if you Google that, you can find that. Basically, what is involved with that is scholars look at satellite views of land features on Earth. They then categorize, one of our big ideas, categorize those satellite views into formed by water, formed by air, formed by volcanic processes, or formed by impacts due to meteors or meteorites. And so once they have that info, you can even expand it further to look at satellite views of Mars, moons of Jupiter and other areas, and say what processes are happening on Io that's around Jupiter right now based on what the surface of Io looks like. Real-world connections will be very easy for the Earth and Weather unit. There is a whole lot of examples about basically people versus the environment that you can bring into your classroom. We can deal with mining, fracking, drilling for oil, using cars that produce greenhouse gases. Are we causing erosion due to acid rain of natural landforms? Are we increasing flash flooding by having too much concrete in cities? Are humans' processes accelerating or intensifying natural processes like weathering, erosion, hurricanes, earthquakes? And are we contributing to climate change? So you should be starting this around the second week of November after finishing your physics unit. It is important that you have time before CA number 2 to complete all the parts of plate tectonics, topographic maps, and satellite views, because those are readiness standards on the STAR test. Usually I only spend 1 day on it, and it makes a very good segue into the rest of the unit. I'm trying to bring in some more CER writing for my formative assessments, so notice that I have one for the historical evidence of continental drift in Pangaea. Day 2, I would talk about plate tectonics and how they move. This deals with your categorization of plate tectonics, what different types are there, how do they move. You're talking about convection currents, and that there are 3 types. On day 3, you should probably do a lab. It is totally possible to switch day 2 and day 3 if you want to begin with an inquiry kind of lab and then go into a more in-depth explanation after the lab. So that may be an option for you if your class is ready for that kind of inquiry. By day 4, you should be moving on to some satellite views. Satellite views are a little easier for scholars to understand. They can tell by looking at it what it is, and then use some explains or CER paragraphs to explain what's going on, how they're going to change over time. You should probably bring up weathering, erosion, and deposition when you talk about your satellite views and how these land features are going to change over time. Then I would bring up topographic maps. It's a little easier to visually imagine topographic maps after you have seen a physical representation through your satellite view. So hopefully they can start making some associations between the lines on these maps and some of the shapes that they see in the satellite views. I didn't bother putting day 6 on this virtual unit plan because day 6 and then whatever you have left of your CA time between now and the end of December, you should probably using for review for CA, working through your GRASP assignment, and then maybe the Blue Marble Earth assignment if your scholars are ready for that advanced of a topic. So then we jump forward in time to talk about day 7, which is happening in quarter 3. What I generally do is I start from big picture and go to small picture. So for quarter 3, which involves the astronomy unit and the weather unit, I usually start by talking about the universe, the stars. I bring it into our sun, our solar system, then talk about our sun, moon, earth system, and then get into global weather patterns and then local weather patterns. So I kind of go from a very large, big picture view to a very small local weather patterns view. So you'll notice my date for day 7 isn't till almost the end of February. So I have this as the last 6 or 7 days before CA number 3. I start the first day of weather with convection currents, and then notice also there is an explain or CER paragraph for the formative assessment. Next, I talk about the global wind patterns, which still merges the supporting standard of convection currents and global winds, and then also how they influence weather maps and local weather. So again, there is a CER paragraph or an explain question to influence scholars' writing. Then I'll talk about the different air masses and how they can affect local weather, which leads us into weather maps. So the weather maps are more detailed expressions dealing with pressure, fronts that influence the daily weather systems in their area. And then lastly, I talk about hurricanes. If I have time, I will also talk about tornadoes, because tornadoes are happening in Texas. If you have any questions or concerns about this unit plan, please feel free to contact me at atroxel@uplifteducation.org. Thank you.